All right, is everybody on page 10? How does this equation differ from what you did yesterday and the first half of today? Nicole. One more time because I didn't hear you. You're doing two things to the variable. What are you doing first to it? By how much? Because everybody see you have that 6x, which means you're multiplying it by 6. And then you're doing what? You're adding 3 to it. So we kind of tackle this the same way as we did one step, but here's the key. You know, when you do your PEMDAS, what comes first, multiplication or addition? What would come first? You can say it out loud.
Multiplication.
When you undo it or work with inverse operations, you do reverse PEMDAS. So you will have to take care of, when you do your railroad tracks, you'll have to take care of undoing the addition first, then doing the inverse of the multiplication, if that makes sense. All right, well, anyway, let's just kind of jot out what we just talked about. It's different from the last because we're doing two things. Two operations. First, we multiply the variable by 6, and then we're adding 3. Scroll up just a little bit. The way we're going to tackle it, or do it when we do our railroad tracks, is first you take care. Can I scroll this up? You good still? I'll leave that there. First you take care of any addition and subtraction. You undo that inverse operation that first, and then take care of all multiplication and division last. Okay, now when you look at these, when you see these problems, they're going to be coupled together as multiplication or division with addition or subtraction. So when we say two-step, it's going to be two different operations. It's not going to be multiplication and multiplication or addition and addition. There'll be two different ones. Okay? Take care of addition subtraction first. You undo that first, and then you worry about your multiplication and division. So if we undo in reverse PEMDAS, in the above example, 6x plus 3, which I'm just going to write down here so not to scroll up. What do you have to do? What inverse operation would you have to do first? What do you have to undo first? Nathan?
Add 3.
Well, you're already adding 3. You got to do the opposite of adding 3. You would first have to take care of subtracting 3. Which we'll do on the next page. Then what? 10. You have to then divide by 6. It's going like in reverse PEMDAS inverse operation. I'll show it to you on the next page how it looks when you track it out. Where is it? I'll find it. Okay. So, is this your next example?
No.
Yeah. Oh, you have your 6 at page 11. Oh, let me find it. Oh, there it is. Okay. So rewrite it. Now you're going to see you're going to need more room, so don't write too big. I want you to make your railroad tracks, but don't put in the little equal signs in between yet, because I don't know where that's going to exactly lay out. All right, now watch carefully. We're going to subtract 3 first, right? Because you said that you can do the opposite of adding 3. So you subtract 3. What do you have to do to the other side? Shane. Also subtract 3. Now here's where this is going to be different. What's canceling out on the left side? Nate.
Canceling out on the left side is plus 3.
And and minus 3, right? But here's what's different. What's still left after that cancellation? Right, 6x is still left, not just x, because we haven't done anything with that 6 next to the x yet. So I'm going to rewrite what's still left, 6x. Now I'm going to make another equal sign, because you have to do 27 take away 3. It's 27 take away 3. 24. And now to take a look at it, you're kind of right back where you were in day 1. Now it's back to one step. So what do you do next? Ellen? Right, you divide by 6, because the x is still here. You have to do the opposite to it. Just divide by 6. What do you have to do on the right side? X. Correct. What cancels out on the left side? Yup. Say goodbye to the 6's. What's still left? X is left. Almost done. 24 divided by 6. Got it. Circle it. Now, before we show the check, let's be smart. Let's do a mental check. Make believe x is now 4. What is 6 times 4? 24, right? Plus 3. It works. That's all really what that's all what a check is. It's just substituting what you get in. You just have to show it. Yeah. Where did I get the minus 3? From the plus 3 that initially started in the equation. Because the opposite of add 3 to this expression 6x is minus 3. Okay? Okay, here's the check. Rewrite original exactly as is. And kind of like what we just did mentally, you're just going to actually do it by writing it in. So now it's 6 times what? When I substitute in? Times 4. Now when you do the check and you do PEMDAS, you got to do it in the correct order. So when in your check, it's regular PEMDAS straight up. You got to do 6 times 4 first, which is 24. Bring down the plus 3. 24 plus 3 is, and that's a perfect showing of work. If you're good with one-step equations, 2 steps not going to be that bad. Some of you are still just on the verge of getting 1 step, so you might need more practice with 1 step before you do 2. Let's practice another one. Okay, 12x minus 8 equals 136. Make the tracks, but don't make the equal signs yet, if you don't know how much space you need. Oh, I don't want that. All right, what do you do first? Shane. Right. Undo the addition or subtraction first. In this case, it's subtraction. So the opposite of minus 8 is plus 8. What do I have to do the other side, though? Right. Hey, what cancels? Come on, minus 8 plus 8. Dan, what's still left on that side? I still have to do 136 plus 8. Again. Try it again. Try again. going to get it. Third time's the charm. Third time's the charm. Now what? Carly, what do I do next?
12x that. So 12x divided by 12.
Correct. Divide by 12. Now what? Correct. Got to keep it balanced, so whatever I do on one side, I got to do on the other. What cancels? Nick, what's left on that side?
X.
144 divided by 12. Goes evenly.
12.
Yep, 12. Let's do a mental check just so we could kind of make sure. Okay, if I substitute 12 in, what's 12 times 12? 144. What's 144 take away 8? Looks like it's going to work. We just have to show it. That's the original. That's after we sub in 12. Do that first. You get, like we said, 144. 8. You can, yes. I don't know if I have decimals in the second set or not. I don't remember if I do, but sometimes you will get a decimal, yeah. I'll take a look. Maybe we do. I'll let you know for sure after I look at the cake. Let's do one more together. The more that you see it, the more it's going to help. What page is it? 12 coming up?
12.
Holy moly. Everything's jumping around here. Where's my 12? Ah, there's the 12. All right, 59 equals 7n plus 10. Track. Do you guys have enough room to work? Tight. All right, Carson, what side has the variable? What's being done to it? What do I have to undo first? Okay, by how much? Opposite of add 10 is? I'm just going to go into that you automatically know whatever you do on one side, you can do on the other. 90 stack, what cancels out? What's left on that side? Don't let it confuse you if that variable's on the other side. It'll still work out perfectly. Okay, 59 take away 10. All right, now what? Halfway home, what's next? Ellie, you want to try it? Well, what side still has a variable on it? What side, right or left? What's being done to n? By how much? What's the opposite of multiply by 7? By how much? Christian, what cancels? What's left? $49 divided by 7. Goes in evenly. Say it out loud, everybody. Don't let it confuse you if you see the n on the other side. N equals 7, 7 equals n is the same thing. You could flip it if you wanted to. Do a mental check. Here's my 7. Substitute in. What's 7 times 7? Take away 10 or add 10. 59. You know it's going to work. We just have to show it. That's my original. Here comes the sub in. Try 3 all by yourself. I'll do a walkthrough.